Okay, we're going to do lesson 15. 5.4 from the textbook, Finding Linear Equations. Okay, now there's different ways to do this, and I'm going to focus on one, but I will mention the other one time just in case people are used to that and have already learned it, but via the alternate method. I'm going to be sticking with what's called point-slope form of a line. It's a equation of a line in a form that we don't want to leave it in this form. We will want to convert it at the end to our usual slope-intercept form, y is equal to mx plus b. But this is good when you're setting it up and trying to find that equation, because what it does is it takes inputs of m, which is the slope, and you will just fill in the m right there with the actual slope that they give you, or that you compute. And then you have a point. If you know a point on the line, you can use those coordinates of the points and plug them in there and there. And the x and y, just the x by itself and the y by itself, those are your variables. Nothing happens with those other than that's the y and that's the x that ends up in your final equation of y is equal to mx plus b. But everything else gets filled in with numbers. You're going to take your slope and fill it in right there. You're going to take the coordinates of the point that you know is on your line, and you're going to plug in the x-coordinate here. You're going to plug in the y-coordinate here. And then you'll just rearrange it and get the y by itself and put it into slope-intercept form. Okay, and let's do one of these right now. Let's get familiar with using this. So the instructions here will be to find the equation of the line with the given criteria. And I will give you different criteria in different situations. Once you set it up using point-slope form or the other method that I'm going to discuss, you want to give your answer, your final answer, in slope-intercept form. Meaning you want it in the form of y is equal to mx plus b. Provided it's not a special case, this is for slanted lines. And by the way, special cases are going to be mixed in here. We will learn how to handle it. We will handle it very differently. We won't even use that because that won't even apply to certain situations. So we will have to be aware of special cases, and I'll address them separately, but they'll be mixed in with these. Okay, so let's start doing this. The criteria for our first line is that the slope is 2, and the point that the line is passing through. So sometimes they'll say passing through. Sometimes they'll say contained. It contains the point 3, 1. Or passes through the point 3, 1. Or the point 3, 1 is on the line. There's different ways to say it, but the idea is we want a line that has slope 2 and that passes through the point 3, 1. Okay. Let me just mention our slope obviously is a 2, that's our m. And the point that they give you, that you know your line is passing through, is we're going to label it x1, y1 and plug them in there and there. So let me just remind us that x1 is 3, y1 is 1, and let's start using point slope form. I'll copy it down first. You don't need to copy it down every time, but I'll mention it is helpful because I want to look at that and literally fill in right below. I'm going to start filling in everything that I know. Again, keep in mind that the y and the x are going to stay y and x, but everything else is going to be filled in with numbers. So I'm going to start y minus y1. The y stays y. The y1 is that coordinate right there. It's 1. So that left side is y minus 1. My equal sign is there. I'm going to fill in the slope m, which is 2. And in parentheses, which are important, it's part of your formula. The x stays x. The x1 gets replaced with the x-coordinate of the point 3. And technically that's that's an equation of this line that satisfies that criteria. It's not the form we generally want it in. It does say specifically they want slope-intercept form, and even if they don't specify that, that's generally what form you want to give your answers in typically. So sometimes it's just a convention. You give your answer in slope-intercept form if it's a slanted line. Okay, so I want to get the y by itself. I will be moving that one over eventually, but before that, let me just get rid of these parentheses. There's no parentheses in y is equal to mx plus b, so we'll get rid of it by distributing. It's going to be 2x minus 6. And now I'm ready to add the 1 to both sides to get rid of it on the left, leaving y by itself on the left. I get y is equal to 2x minus 5. Okay, and if I've done everything correctly, it should be a line that has slope 2, and it should be a line that passes through or contains a point 3, 1. How can I check that? This is optional, it's not necessary. If I did everything correctly, I'm fine. But if I did want to check it, first of all, I can glance at it and verify the slope is 2. So check on that. How do I know what this point is on the line, this line? We've done it before, where you actually check if these coordinates satisfy the equation. So I'll do that. I'll rewrite it here. And I'll replace the y with the y coordinate of the point that supposedly satisfies it. So I'm going to replace it with a 1. I'm going to replace x with 3. So I have y is equal to 2 times x minus 5. And if I plug in 1 comma 3, what happens? It satisfies the equation. I get 1 is equal to 1. Check. So this is a yes, this point is on that line, and that confirms it satisfies the criteria. This line has slope 2, obviously, and contains that point because those coordinates satisfy the equation. Okay, and we're done. We're going to do more practice with this. Eventually we'll encounter special cases, but I just want to mention, some people have learned how to find the equations of lines using a different technique, and I don't want to leave them in the lurch. If they learned it before and they were good at it and they were comfortable using that other method, I don't want to stop them and force them to use this one. But maybe they forgot how to do it, maybe they need a refresher, so I'm going to take some time. If you're good with this, that's fine, and you can practically ignore this. But I'm going to do the alternate method, and I don't know what the term is, or what they call it. I'm going to just say it's solving for b. I'm going to do the same problem though. Okay, so we're going to start off. We jump straight to slope-intercept form. And to get our answer, what we need to know is m and fill that in, and b and fill that in. The m we got right away. It's slope 2, so I can fill that in right away. But I don't know the b. That's a mystery as of now. And I'll leave it as b, an unknown b. But I got to find it to get this answer. What other piece of information do I have? I already used the slope. The other information that I have that I have to use is the 3, 1, that it satisfies this equation, that it's on this line. So I can do what I did with the check over there. I can plug it in. I'm going to plug in the 3. Sorry, I'm going to plug in the 1 for y. I'm going to plug in 3 for x. This time I'm pretending I don't know this, so I don't have any answer. I don't have that equation. All I have is this y. I'm going to fill in y is equal to 1 is equal to 2 times x. That's coming from the slope that I know. And I don't know what b is as of right now. But I can find the b that makes this work, which is what I want to do. So I'm going to solve it for b. Multiply this 3 times the 2. Subtract 6 from both sides. And the b that'll make this work out is -5. Okay, that's not your answer. This wasn't solving an equation. It was giving the equation of a line, which was kind of right here, except I was missing that one piece of b, and now I have it. So my actual answer is y is equal to 2x plus a -5, which is I think is -5. Okay, so that's a different method of doing it that some people learn, and by all means stick with that if that's what you're used to and you're comfortable with that. If you like the point slope form, that's what I'm going to be using, so either way is good. We should get the same answer as long as we do everything correctly. Instructions are the same. We're going to do a bunch of these. Find the equation of the line, set it with the given criteria. So part B, I guess. I labeled it part A, part B. Okay, I want you to do this one on your own. Slope is -3, so same idea. It'll have a lot of negatives though that you have to be careful about. So slope is -3, passing through the point 2, -4. Hold off and don't start yet. I do want you to attempt it on your own. But I'm going to mention that the formula has y minus the y coordinate over here and x minus the x coordinate of your point. And when you have negative coordinates in there, that means you're going to be subtracting a negative number. So be careful about that when you set it up. So a lot of times you'll have, again, minus a negative number. Pause the video here and see if you can work it out on your own. I'm going to start. My y1 is -4, so right there I have that issue that I talked about. I have y minus a -4. So equal to -3 times x minus, the x coordinate is just a regular 2, so I'm going to just put -2. And that's my setup. I'm going to get the y by itself. So first, don't start moving things around when you have this minus negative. Any minus negatives you have in either there or there, cancel them first before you start working this equation. So let me just rewrite it as y plus 4. Just get rid of those minus negatives, cancel them out, get it clean looking, and then we got to do what we did before. I'm going to distribute this -3. It's going to be -3x plus 6. I'm going to have to subtract 4 from both sides to get into slope-intercept form. Y is equal to -3x plus 2. And if you're confident you did everything correctly, you can just go with that as your answer. You don't need to check, it was just an option. It definitely has slope -3, but the only way to verify it goes through that point is to plug that point in, those coordinates in, and verify it, but you do not need to do that, that's an option. So don't worry about it. Okay. C. Slope -2/3. Passing through -6, 2. Yes, you're going to have to deal with fractions here. That's why we spent so much time in lesson 3 making sure we have it down, because it's going to come up in these equations occasionally. A lot of times I'll illustrate things with whole number problems, and then you will be expected to be able to adapt it to fractions. Nothing's different. You just have to worry about fraction multiplication, fraction addition possibly. Remember when you need a common denominator, when you don't. It shouldn't be too bad. And I would pause here and make sure you can do it on your own. It's the same thing. You do have to work with fractions, but nothing new, so it is something you should be able to tackle now. Or at least attempt to tackle. Maybe there'll be problems and you'll get stuck, but it's better if you work it and get stuck and then see how it's done versus just sitting back and watching me do the entire thing. Okay. I'm going to have y minus 2 on the left. I'm going to have a -2/3 as my slope times x minus a -6. And one thing that I see people do is try to just distribute it into here like that. That is not going to go well. You should simplify that first within the parentheses. You can't combine them, but you can definitely rewrite this as x plus 6. And I would do that before you attempt to distribute the -2/3. So let me just rewrite it first. And then now I have to distribute, but it's going to be a lot easier for me to remember my signs and get my signs correct if I have it written like that. By the way, in the future, starting from now, when I know it's going to be x or it's going to be minus a negative coordinate and I'm going to cancel those negatives, in the future I'm just going to go straight to this. I'm going to see y minus 2 equals, my slope is negative 2/3, and when I see the negative 6, I know it's going to be x minus a negative 6, and I'm going to immediately write plus 6. Same thing here, I would have just skipped that and gone straight to plus the negative, plus the coordinate. Alright, so be aware of that. I'm going to start skipping the step of writing it as minus negative and just go straight to plus in those situations. Let's talk about distributing. Negative 2/3 times x. It's just negative 2/3 x. Negative 2/3 times a positive 6 will be a negative. As far as what it's equal to when I multiply them, I will need to rewrite that 6/1. So what I'm trying to do is, to recap, I'm just trying to figure out what negative 2/3 is times that 6 because I'm distributing. And so that's what I'm trying to do. A fraction times a whole number, and we've done that before. The way you handle it is make them both fractions by putting that 6/1. Let me write on the left side. I'm not doing anything with the left side. I'm focusing on that and cleaning that up first, but let me bring everything down so I don't lose track of where I'm at. And then you do your fraction multiplication. Remember, if you need a common denominator or not. You do not for multiplication. We're ready to go. I can cross cancel for multiplication. A 3 goes into it, the 3 and the 6, so I get a 1 and a 2. And so it's going to be minus 2 times 2 over 1 times 1. So that'll just be a minus 4. A lot of times, even though you're working with fractions, the constant term will come out clean. And I can just finish up by adding 2 to both sides. And fortunately, I don't need to add any fractions. You might have to in the future. On the homework, there's one where you will have to, this adding, it'll be fractions, you need a common denominator. But here it's fairly clean. We do have a fraction slope, but everything else came out to nice constants. Y is equal to negative 2/3 x minus 2 is our answer. I'm going to pause it there. We have more to do. We have not encountered special cases yet. We will soon, I assure you. Okay, same instructions. Where was that? A, B, C, D. I think I'm on D. Slope is undefined. Immediately that means it's a special case. You will have to start looking through your notes right now and figure out which type of special case it is, what the form of it is. Passing through 2, 5. Okay. And so you're definitely not going to use point slope form because you can't plug in undefined for m and distribute undefined and work with it mathematically. So you have to recognize that this is immediately a special case. And you need to know which type of special case. Undefined slope is a vertical line. And instead of working out your equation via point slope form and getting into slope intercept form, you know your answer is going to be x is equal to blank. That's it. Vertical lines are of the form x is equal to some constant. I mean, that's not it because I got to find what that constant is. So that's going to be my issue is what number goes there, and it's going to be x is equal to something. Now, this one time we're going to graph it, but then I'll show you a shortcut of where you can just grab it from the information that's above. But here, and don't hesitate to graph it. For the special cases especially, it's easy to visualize vertical and horizontal lines and get a feel for where they are. Specifically because this one, we know it's going to be a vertical line because of undefined slope, and we know it has to pass through 2, 5. So let me just go ahead and graph 2, 5. And this is just a very crude graph. 1, 2, 3, 4, 5. I'm not graphing it super detailed. I'm making it very small because I don't want to waste paper just to get this idea of where this line is going to be. Because I just want to know where it is. Is it here, there, there? Specifically, got to go through that point that I just drew. And so it's going like that. It's got to be a vertical line with undefined slope passing through that point, 2, 5. And I'm putting more detail than I need just for notes purposes, for the lecture purposes. You don't need to do all that. You just need to get a feel for where it is. And once you know it's there, then you know the equation of it is x is equal to 2. And that's it. That is your answer now. X is equal to 2 is the equation of a line that has undefined slope, making it a vertical line, and this line does pass through 2 comma 5. And the way I can do it without graphing it, and again, don't hesitate to graph if you're stuck, is x equals something, and it has to pass through this point, and 2 is my x-coordinate, and 5 is my y, and since it needs to satisfy it, basically, it has to match up with that x-coordinate. So I can know it's x equals 2 purely because it has to match up with the x-coordinate of that point that it's passing through. And so that's it. E. Slope is 0. And passing through 1 comma negative 3. Okay, slope 0 is also a special case. 0 is a number. You could in theory work with it like any other slope. It is completely valid, but I will note that that 0 is also a special case. You would go through your notes and figure out what type of special case, and it is a horizontal line. Horizontal lines are the lines that have slope equals 0. Okay, and what's the form of a horizontal line? Y is equal to some constant. So there's my answer. I'm not done with it because I got to figure out that constant, but I know it's going to be of that form because I know it has to be a horizontal line. So it's going to have the equation of a horizontal line, which is of that form. All right, and if you know the trick here, basically that constant there has to be matching up with the actual y coordinate of the point it's passing through. So it's going to be y is equal to negative 3. If I don't remember that, and I don't really understand that, by all means, let's just graph it out. 1 comma negative 3. Is 1 comma negative 3 right here. You don't have to label it in your note, or I mean you can for you know partial credit and things like that, but I'm labeling it specifically so you can see that that's the point 1 comma negative 3. Our line is going to pass through that point. It needs to have slope 0, and we know that slope 0 means it's got to be a horizontal line through that point. And there it is. That's the line. That's a graph of the line we're looking for, and we want the equation of that line. And it's y is equal to, that's right, negative 3. And we're done. Okay, so undefined slope and 0 slope are both special cases. You cannot work with undefined slope in the way you've been doing with other slopes. However, I mentioned it, the 0 can be treated like any other slope, and you don't have to recognize it's a special case, and you can work with it. And I'm going to do it one time in case people forget that 0 slope is a horizontal line special case, and just start working with it. You can use point slope form, so this is an alternate method of doing this problem. But because I see people attempting it and then not knowing how to handle that 0, I need to go through it. Okay, so I'm just going to use point slope form. That's going to be y plus 3, because it's going to be y minus negative 3 equals 0. 0 is a valid number that I can plug in for my slope and work with, multiplied by x minus 1. That's the setup for using point slope form with 0 slope. And now I distribute. 0 times x is 0. It's just gone. 0x is gone. 0 times negative 1 is also 0. 0 times this whole thing is 0. You have no x. It wipes everything out, like any other thing. Doesn't matter if it's variables and constants or an expression, 0 times anything is still 0. 0 times anything is still 0. I'm going to finish up by getting y by itself, and I'll just subtract 3 from both sides. Get the y by itself. Oop, I don't get 0, sorry. Y is equal to negative 3. And that matches up with the way we did it there. So either one is valid as long as you know how to handle the 0. And remember that 0 times everything in that is parentheses wipes it out and you don't have any more x in it. That's how you get a horizontal line out of this. Okay, so special cases, they'll come up again. Here I specified 0 slope and undefined slope. But the next sort of problems are going to involve us being given 2 points and no slope. So we'll talk about that right now. Okay. Same instructions. We're going to find the equation of a line with the given criteria. I'm going to start over with A, B, C, and so on. I don't want to go too high. with the letters, but we'll just do several of these to cover all the different situations you encounter. So it's the same instructions, but the criteria is going to be different now. You're going to be given 2 points through -3, 6, and -1, -2. So now you're given 2 points. And when you have 2 points, you don't have to draw this, but when you have 2 points, there is a single line that goes through them. You can always draw a line, a unique single line through them, and there's an equation to that line if it's in your Cartesian coordinate plane. So it'll have to have an equation. There's one equation that will be a line passing through both of these points. Okay, what we're going to do is we're going to use point slope form again. However, we don't have the slope. What we need for point slope form is the slope, which we don't have, and we need a point, which we have 2 of. So we can choose either point to use for point slope form, but we need the slope. It was not given to us. However, the reason they give us 2 points is so that we can find the slope, doing what we did in the last homework. You know how to find the slope of the line between 2 points? We're going to do that first. I'm going to do this rather quickly. It's going to be -2, this is x1, y1, x2, y2. I usually write them side by side, but so -2 minus 6 over -1 minus a -3. Watch your negatives and subtracting negatives and whatnot. Now I'm going to get -8 up top. That would become +3, so +2 on the bottom, and that gives me a slope of -4. Okay, I'm going to circle it. That's not my answer, but I just want to make sure we know that that's the first piece that we'll need. Once we have that, we can use point slope form. So n is going to be -4, now that I know the slope. And I need the point. Which point should I use? It doesn't matter. I mean, I would have labeled that x1, y1, x2, y2 for my slope, but for the purposes of the next step, you can just pick whichever one you want. I'll go with this first one, x1, y1. So it's going to be y minus 6. I'm going to go through this a little more quickly than I've been doing. Y minus 6 is equal to, my slope is -4, times x plus 3. I mentioned I'm going to start going straight to plus when it's minus a -3. I'm just going to go right to +3. Okay, I'll distribute -4. I'll add 6 to both sides. And I'll get y is equal to -4x minus 6. That's it. That's the equation of a line that passes through these 2 points. To verify it, you would have to make sure both points satisfy it. So if you really wanted to verify it, you have to try out -3 and 6 in there and make sure that satisfies that equation. And you'd also have to try out -1, -2 and make sure that satisfies the equation to check it. Honestly, it's probably not worth it. I would just be extra careful with your steps here, and then, you know, your answer should be good. Okay, I do want to address something here because I chose to go with the first point and the slope that we found. But what happens if you use the other point? Supposedly both of these points are on the line, so both of these points should serve the purposes of point slope form. So let me redo this. I don't have to, I'm done. But let me just convince you that if we use the other point instead, we'll get the same equation. So this time it's going to be y plus 2, so I'm doing minus a -2. My slope is still the same, I'm just choosing a different point. It's going to be x plus 1. And now distribute -4. I'll subtract 2 from both sides. Y is equal to -4x minus 6. So it does give you the same equation. All right. So either point works with point slope form, but you will need to use both of them to find the slope first. All right, I want you to do B on your own through the points -5, 9, and -1, -11. Same process, you're given 2 points. You're going to use point slope form eventually, but not yet. You need to first find the slope that you're going to use. So first step, find the slope. Second step, use that slope with either point in point slope form. Okay, I'm going to start, but I do want you to pause it and make sure you can work this out on your own. It's worthwhile for you to try to work things out on your own. Even if you get stuck, it's better that you work it through to the point that you get stuck, then see how it works out, and then hopefully it clicks by that point. But it doesn't really click if you just watch me passively. Now I'm going to start. Slope is -11 minus 9 up top, and then -1 minus a -5. I'll get -20 up top, positive 4 on the bottom, and my slope is -5. Alright, I'm not going to always do both points to convince you, but either point will work and give us the same answer provided we do everything correctly. I'm just going to go with the first one. Y minus 9 is equal to -5 times x plus 5, because I'm doing minus -5. I'll distribute that -5. I'll add 9 to both sides. Y is equal to -5x minus 16. Bigger numbers than I usually give you, but yeah, that's valid. -5x minus 16 is the equation of the line passing through these 2 points. Okay, a couple more of these, and then another type of problem. Like I said, this is mostly just doing point slope form, other than when you encounter special cases. Oh, this is part C, sorry. Passing through -4, 2 and -4, -3. Hold on. Okay, you can start doing this one if you want. Something weird's going to happen. This is going to be a weird situation. Not that weird, but you'll see. I'm going to do my slope formula first. -3 minus 2, and on the bottom -4 minus a -4. Make sure you don't do -4 minus 4. It ends up being minus a -4 becomes +4. We end up with -5 up top and 0 on the bottom. So we get a 0 on the bottom. You have to remember what that means. 0 on the top is fine. You can do 0 divided by anything and you'll get 0. You're not allowed to divide by 0. They say that all the time, that you can't divide by 0, and here that means undefined because you're trying to divide by 0. So there is no answer here. Your slope is undefined. However, you are not done. They didn't want to just find the slope. They wanted the equation of a line, and there is an equation of a line that goes through these 2 points. The fact that we got undefined slope just tells us that it is a special case. It's one of the special cases of horizontal or vertical lines. I would go flip through your note to make sure you know which one it is when it has undefined slope. This is a vertical line. We did it earlier. Once we recognize it's a vertical line, we know that our final answer will be a very special type of equation of the form x equals some number, x equals blank. That's my answer right there, other than I haven't figured out what that constant is, but I just got to figure out that constant and I'll be good. That'll be my answer. The equation of a vertical line. Now, I'll give you, I did talk about it, yeah, the shortcut, okay. So, the shortcut was to just note that for it to pass through those points, it has to be x equals, and that has to match up with the x coordinates of a point, any point that it passes through. The question is, which point? If I look at that one, the x has to match up with the x coordinate of that point, which is -4. What happens if I look at the other point? X has to match up with the x coordinate of that other point since it's passing through that. Fortunately, they're both the same. In fact, they have to be both the same. That's how you get the 0 here. If they're not both the same, or if you get a 0 here and you don't have the same coordinate, it means you messed up. But okay, so it's x equals -4. Because that's the x coordinate of both points that it passes through. Let's pretend we don't know that. Because again, I don't want you to, if you're not clear on that or it's not clicking, it's fine. because here with special cases, one of the good things you can always do that'll be very helpful is just graph them. Not a real detailed graph, I just want a rough sketch to know where these lines are going, or this line rather is going. I definitely want to be able to graph both points here. I don't know, I'm putting way more detail than I need, but I'm going to start graphing these points. Negative 4, comma 2, 2, right there. Negative 4, comma negative 3. And I'm looking for the equation of the line that passes through both points. It is indeed a vertical line. When I draw it, I can definitely see it's a vertical line. It's of the form x equals, as I had before, and you just got to see where it is. You've got equations of vertical lines from a graph, and it's just x equals negative 4. So either way, graph it, or recognize that basically both points has to satisfy it, so the x-coordinate has to be negative 4. Okay, next. I'll just put it here, D through 2 comma 3 and negative 4 comma 3. So if you can work this one out, a similar thing happens, so keep that in mind. Okay, I'm going to start, unpause it. Slope 3 minus 3 over negative 4 minus 2. Like it 0 up top, make it negative 6 in the bottom. You can do 0 divided by any number. 0 divided by negative 6 is a valid computation. It equals a number. That number happens to be 0. And that is your slope. And you can work with that in point slope form. But I did talk about that it's better to well, I don't say it's better, but I'm just going to recognize that that is a special case. And rather than working with that 0 in point slope form, I'm going to note, flip through my notes and note that that is a horizontal line. I'm also going to note that the equation of a horizontal line is of the form y is equal to some constant. And know that my answer is going to look like that. I just need to figure out that constant. And the shortcut is to note that it has to be the constant that, such that it's y is equal to that has to match up with the y coordinates of both points that it passes through. It has to match up with the y coordinate of that point. It also has to match up with the y coordinate of that point. They are the same, so it's y is equal to 3. And if not, by all means, let's just graph it and let's see what it looks like. Okay, what have I got? 2 comma 3 up here. Negative 4. Oops, I didn't show negative 4. Let me just add on a little bit of extra. Negative 4 comma 3 up here. The line that passes through those 2 points, as we suspected, is a horizontal line. And it has to be of the form y is equal to. And where's that? It's 1, 2, 3. Because both y coordinates are 3, that line will be at a level of y is equal to 3. And that's it. Special cases come up in these as well, where you're given 2 points. It happens when you get a 0 on the bottom, that's undefined, a vertical line. If you get 0 on the top, that's slope is 0, and that's a horizontal line. But if you get anything other than those, then you're going to have to use point slope form and get a slanted line, and your final answer will be in the form y is equal to mx plus b. Okay, and you have a calculator for all of these, so feel free to use it, but don't rely on it. However, there's going to be instructions and problems on this particular homework. Where am I at? E? That'll specify they want you to use a calculator. I'm going to just put that in brackets because it's the same instructions. You're going to find the line with the given criteria, find the equation, find the line, find the equation of the line. I should have wrote that, but you get the idea. Okay, so this one's going to pass through the points negative 2.5, comma 7.6, and 1.5, comma 2.8. Okay, so I'm getting you prepped for when we start working with models, linear models in real life applications like you did in homework 12, but with equations, the data's not going to be as nice. It's not going to be nice whole numbers all the time. So we'll have to use calculators and possibly round. Now these problems, even though you're using a calculator, you're not going to have to round. We're going to have to learn rounding and refresh our memory and remind us of the rules of it in a later homework, in a later section. So for these, you just proceed in the usual way and it'll come out to semi-nice numbers. They'll be decimals but terminating and you won't have to round. Okay, so we'll do this one together. But as far as what we're doing is just treating it the same way. 2.8 minus 7.6 over 1.5 minus a negative 2.5. And whereas I was just doing things in my head because they were nice whole numbers, not so nice now, but that's why it's specifying you can use a calculator for this. You can use a calculator for any of them, but this one, I definitely want you to not be doing any kind of hand computations and carrying ones and borrowing when you got to subtract. Nah, these, I just want you to use technology for it. I'll get negative 4.8 up top. I will happen to get a nice whole number on the bottom, but I still got to divide. And I get negative 1.2. So I didn't have to round. It's a decimal slope, which can happen. I didn't have to round. We will be doing it later where we have to round. But here I just keep working with that. All right, that's my slope. Let me circle it, even though that's not my final answer. Next step is to use point slope form with either point. I'll just use the first one. So I'm going to use this. I keep writing the point slope form first. It's a good habit, but you don't need to. You just go straight to plugging in the values. It's going to be y minus 7.6 is equal to negative 1.2 times x plus 2.5. I'll do the same thing that I did before, other than grabbing my calculator to do the computations for me. I'm going to distribute first. Negative 1.2x times x is just negative 1.2x. Negative 1.2 times 2.5 is, I don't know. Let me figure it out. I know it's going to be negative, so I'm going to put the minus there. And I'm just going to do 1.2 times 2.5 to figure out the value. 3. A nice whole number of 3. Yeah, I guess so. Okay. That can happen within here. Final answer will be decimals, though, because I'm going to now have to add 7.6 to both sides. That adds with a constant term there. So very similar, other than it looks uglier than it is. Y is equal to negative 1.2x, and you should keep track of the signs on your own. That's a negative added to a positive. That's opposite sign, so I've got to find the difference. 7.6 minus 3, 4.6. I got to decide whether it's a positive or negative. It was a bigger positive, so that's plus 4.6. Yeah, and that's it. So nothing different other than I am expecting to use a calculator to do the computations, but the process is still you doing the exact same thing as before. We got one more type of problem to do. These are tricky. I'm going to pause it here, but I got to worry about this next type of problem. Okay, next problem, we want to find the equation of the line. Passing through two comma 1 and parallel to the line y is equal to 2x plus 1. Okay, so we're looking for the equation of a line. We know it has to pass through the point 2 comma 1, and it has a particular relationship with this other line that they're giving you. And we're going to do this computationally. You don't need to graph it to do these. It may not be that helpful to graph. It's definitely not going to get you the equation. It can help you to visualize what you're trying to do. So I'm going to do this one time, just to make sure we know what we're doing. But we will be doing it computationally to get the equation of the line. Okay, so I'm going to graph the point. Okay, so we have the point 2, 1. And we want our line to pass through that point. I don't know what direction it's going to go. Well, I kind of do because I know it needs to be parallel to this line, y is equal to 2x plus 1. So let me graph that. I'd start at 0, 1, and then go 2 up and 1 over. So it's going to be roughly this. This is just kind of just a rough sketch. Okay. And so we're looking for the equation of the line that passes through this point. I'm going to draw it in blue, parallel to this other line that they're giving you. So there's 2 lines involved in this problem. The black one is their line, the line that they gave us, which has the equation 2x plus 1. And our line, which I haven't drawn yet, which needs to pass through that point, and then I'm going to draw in blue, and that needs to be parallel to this line. So it's going to go like this. Actually, let me just draw it in. Let me just draw a parallel line. It'll look like that. Okay. Yeah, I'll just, okay. May not be accurate. Don't rely on looking at this graph and getting your equation off of that, because this is a hand-drawn graph, kind of half-assed. More importantly, we're going to use point-slope form. Okay, for point-slope form, for our blue line, ooh, that doesn't even look parallel. Let me just fix it. Yeah, okay, let me just bend a little. All right, to use point-slope form to find our blue line, we need a point on our line. We got it, 2, 1. So we're just going to use 2, 1 in point-slope form. We also need the slope. They didn't give us a slope, but they did tell us it's parallel to this line. And now you have to remember the rules for parallel and perpendicular, because there will be problems like this that are involving a line that's perpendicular to a line that's provided. So we have to remember how the slopes are related. They're related. When they're parallel lines, they have the same slope. So the slope of our line needs to be the same as the slope of their line. What's the slope of their line? Well, you look at their equation. If it's already in slope-intercept form, you just pick it out. It may not be in slope-intercept form, so be aware of that. But their slope is 2. What slope should our line be? Since it's parallel, it needs to also be 2. Okay. And once we know the slope that we're going to use with the point that they gave us, we're done with their line. Don't think that one's going to be of any relevance. It's not. The line, the black line, no longer relevant. I know what slope I want. I know the point it's going to go through, and I'm ready to just go with point-slope form. Point-slope form. From there, it's straightforward. It's just a matter of we needed to figure that out based on it being parallel to their line. Minus 2, okay. So putting into point-slope form, flying along, because we've done this many times now. 2x minus 4, I'm going to add 1. Make it y is equal to 2x minus 3. It's definitely parallel to their line, because they have the same slope, and it does pass through 2, 1. I could double check that if I wanted to, but yeah, I guess my graph's not that bad, but I wasn't relying on my hand-drawn graph. I worked it out. 2, 1 was provided in the problem itself. They wanted a line that goes through that point. The slope we had to figure out on our own. So that's going to be a key thing right there. Okay, I'm going to pause it. We're going to do more of this in a bit. Okay, similar problem, so I left it up, but I'm going to erase the point, give you a new point. Find the equation of the line passing through 6, negative 2. And perpendicular to the line ooh, let me fit it. What do I got? 3x plus y is equal to 5. I'm gonna write it in black. So I'm gonna use it in black. Okay, I'm not going to graph this time. It won't really, it's going to get messy when we graph every time. I just wanted to illustrate the idea that one time. The process is going to be similar though. Our line, we need to figure out the slope. We do not know it as of now. We do have a point. We want our line to go through the point. 6 comma negative 2. So once again, we just need to figure out the slope we're going to use, and then we just plug it into point slope form, and then just get it into, you know, y is supposed to be form. Their line is this line. Basically, we're going to find the slope by relating the slopes of their line to the slope of our line. They won't be the same, but the main thing is we need the slope of their line. Don't just grab the coefficient of the x. You need to make sure it's in slope-intercept form first. So this is not solved for y, so we can't get the slope right away. We need to solve it first. And so you do have to sometimes do that solving thing, getting y by itself, getting into slope-intercept form first. So I subtract 3x from both sides, and I get y is equal to negative 3x plus 5. That's their line in slope-intercept form, and now I can conclude what their slope is. Their slope is negative 3. That's the slope of their line. Our line needs to be perpendicular to their line, so now we need to remember how perpendicular slopes look. Perpendicular slopes are negative reciprocals. So we need to take the opposite sign of this slope and flip it. And to flip a whole number, we need to think of it as being over 1. So their slope is negative 3, which we're going to think of as negative 3 over 1. We want to take the negative reciprocal of that for us. Change the sign to positive, flip it, and the slope we're going to use is 1/3. Those are perpendicular slopes right there. They're negative reciprocals of each other. I'm writing your notes. The reason we're choosing 1/3 is because that's a negative reciprocal of negative 3, or negative 3 over 1, but I'll just put negative 3. Okay. One important thing to know is that I've mentioned it before, but I'm going to emphasize it again. Once we know the point it's going through and we figure out the slope that we need to use to make it perpendicular to their line, we're done with their line. You don't even go back to that. Now it's just a problem of finding the equation of a line with slope 1/3 and passing through the point 6, negative 2. You don't worry about that. We're done with that. Let me do it real quick. Right here. It's going to get a little messy. I'm not even going to write point slope form. I'm just going to go straight to it. Y plus 2 is equal to 1/3 times x minus 6. I got to distribute. You don't have to worry about fractions. I'm not going to do it as carefully as last time, so I'm going to fly through this. It's going to be 1/3 x minus 2. I'll subtract 2 from both sides. And I get my final answer. Y is equal to 1/3 x minus 4. That's it. Okay, but it's just point slope form. The issue again is you will need to be figuring out the slope based on it being parallel or perpendicular to a line that they gave you, and therefore you're going to need to figure out the slope of their line. Either use the same slope if they're parallel, do the negative reciprocal if they're perpendicular, and then just use that slope and just do point slope form and forget about that other line once you get what you need from it. And all we needed was the slope. Okay, one last one. I'm going to abbreviate a little bit, the line through, passing through, same thing. So we'll find the equation of line passing through 4 comma negative 3. And parallel to the line y is equal to 5. Okay, in theory, you approach it the same way, but you have to be conscious of special cases. So The line that they gave us here was a slanted line, and we could put it into slope-intercept form and grab the slope. So any line that's parallel or perpendicular to slanted line will also be slanted. This time, the line that they provided, y is equal to 5, is not a slanted line. The slope of it is not 5. Think about what the slope of that line is, and I'm telling you right now it's not 5. Because it's not y is equal to 5x plus something. It's not, there's no x involved. This is not, if you have y is equal to 5x minus 3, the slope of that line is 5 because that's the coefficient of the x. This 5 is just a constant. This is a special case. That is a horizontal line. Now I need to imagine, if I have a horizontal line, y is equal to 5, let me even label it, and I want another line, that's their line. I should have drawn it in black, but that's their line. Our line, let me draw it in black. This is a horizontal line, their line is a horizontal line. I'm not being graphically accurate, I just want to draw a horizontal line and label it y is equal to 5. Our line, which I'm going to draw in blue and be consistent, will have to be parallel to that. And so a line that's parallel to that will be another horizontal line. So my answer is going to just be another horizontal line. We need a horizontal line. Right, there's my answer. Y is equal to something. I just need to figure out what that is. What do I know about this horizontal line? It needs to pass through 4, negative 3. So what's that constant that it has to be y is equal to whatever? Negative 3. And that's working it through logically, but if that's not helping, let's graph it out much more in detail. Let me do the whole graph. Don't hesitate to do the graph for the special cases especially. I said it's not as helpful for the slanted lines because you can't really get the slant accurate. But horizontal and verticals are just left and right or up and down. And here's their line. Y is equal to 5. We need a line passing through 4 comma negative 3. And parallel to their line. So our line needs to be parallel to that. So our line is also going to be a horizontal line. Oops, I misplaced it. Okay, that's the line that we want. Passing through 4 comma negative 3, parallel to y is equal to 5. What's the equation of that line? It's horizontal line, y is equal to negative 3. Perfect, and we're done. Okay, so anyway, 2 horizontal lines are parallel, 2 vertical lines are also parallel. If they want a perpendicular line, then it's going to be 1 horizontal, 1 vertical. So, real quick. If I change the problem, this is a new problem essentially. Find the equation of line through 4 comma negative 3 that is perpendicular to the line y is equal to 5. So now it's a little bit different. Their line is still the horizontal line y is equal to 5. We now want a line that's perpendicular. We need to go up and down. Specifically, we need a vertical line through this. Vertical line is going to be of the form x equals. It has to pass through that point, so it's going to be x equals 4. But if I don't know that, I can graph it out. Their line, our point, this time we need a line that's perpendicular, so it needs to be up and down vertical line. And the equation of that is x is equal to 4. And that's it. So no point slope form with these. We just have to kind of work it out logically and even graph it if needed. So again, 2 horizontal lines are parallel for these types of problems. 2 vertical lines are also parallel. But if you need lines that are perpendicular, they're going to be the opposite types, the different types. There'll be 1 horizontal, 1 vertical. So see if you can work on those. Those are tricky. All of these are tricky where you have to find a line that's parallel or perpendicular to a given line. But just practice with it and text me if you have any questions.